All right, everybody, huge video today. We are going to finish an overview of the proof of semi-stable modularity. So let's get into it. First, we want to look and see that the mod P representations attached to a semi-stable elliptic curve E satisfy conditions A and B. We've actually already seen that though. So let's let E over Q be a semi-stable elliptic curve. We claim rho bar EP satisfies conditions A and B of modularity lifting for every prime P. Condition A was that the determinant of rho bar EP was the mod P cyclotomic character. We already showed that or talked about that in theorem 1 of chapter 1. It follows immediately from the properties of the Vey pairing that you can put on elliptic curves. See Silverman 1 or DDT or Diamond and Sherman for discussions about that. That's a pretty easy proof. Condition B, we want E over Q to be, well, we want E over Q to have semi-stable mod P representation for every prime P, but we have that already, right? Because E over Q itself is a semi-stable elliptic curve. And so by proposition 1 of this chapter, rho bar EP is semi-stable for every prime P at all primes P. So this was already dealt with. Okay. Up next, we want to look at some surge activity and irreducibility properties. So I'll call this theorem 1. So let E over Q be a semi-stable elliptic curve. Then the mod P representation attached to it is either surjective or reducible for all primes P. This is essentially part of the open image theorem of Serre. You can see SPG proposition 21 on page 306. I gave you another Serre reference here. I'll be discussing this result in detail in chapter 7 of my notes. So you're either surjective or reducible if you're a mod P representation attached to a semi-stable elliptic curve. Again, the key word here is the open image theorem of Serre. What we're concerned with is a corollary to this theorem, which says if P is a prime at least 3, then rho bar EP is absolutely irreducible if and only if it's irreducible. And if P equals 3, then either one of these happen if and only if rho bar EP restricted to the Galois group of Q adjoined root -3 is absolutely irreducible. And you remember this was a key part of condition D of modularity lifting from a few videos ago. Let's quickly talk about the proof of this. If you label these 3 conditions 1, 2, and 3, 1 always implies 2 trivially. That 2 implies 1 will be covered in chapter 16 that uses theorem 1. It follows from a more generic fact, which says that if E over F is an elliptic curve and P at least 3 is prime, then if F embeds into R, the irreducibility of rho bar EP implies the absolute irreducibility of rho bar EP. Well, we have F equals Q, so that embeds into R. That 1 implies 3 when P equals 3 will be covered in chapter 14. This also uses theorem 1, the surge activity or irreducibility stuff. And that 3 implies 1 is a trivial representation theory exercise that I encourage you to try yourself. Okay, so let's move on. Let's move on to what I'll call the MIM lemma. That stands for modular irreducible modular. Here's what it says. Let E over Q be a semi-stable elliptic curve and suppose rho bar EP is modular and irreducible for some prime P at least 3, then E is a modular elliptic curve. This is pretty easy to prove. So let's let P be at least 3 by the corollary we just discussed above to theorem 1. Rho bar EP and its restriction to the Galois group of Q adjoined root -3 are absolutely irreducible. Hence, conditions A through D are all satisfied by rho bar EP. You can go back and check in previous videos and look at what conditions A through D are. So we have all the conditions in place for modularity lifting, which was the corollary to Weil's main theorem. What does it say? It says rho EP must be modular. And so by the 5-fold theorem, that's the same thing as E being modular. Okay, perfect. All right, very important theorem here now. I'm going to call this the Three-Five Theorem. It says if E over Q is a semi-stable elliptic curve, then the conditions of the MIM lemma are satisfied by either the prime 3 or the prime 5. If I can show this, I'm done, because then I will have a prime at which rho bar EP is modular and irreducible. And so the elliptic curve E will be modular. And since E over Q was an arbitrary semi-stable elliptic curve, I will have proven what I need to prove. I will have finished the proof of semi-stable modularity, and hence the proof of Fermat's last theorem. And so it all boils down to, can we show the Three-Five Theorem here? To show the Three-Five Theorem, we have to break it down into 3 further sub-theorems. The first sub-theorem 1 I'll just call Langlin's tunnel, although it's really a specific instance of Langlin's tunnel being enacted. Here's sub-theorem 1. Let E over Q be an elliptic curve and suppose rho bar E3 is irreducible. then miraculously, rho bar E3 is modular automatically. This is very deep. So a standard result in number theory says that there's an embedding from GL2F3 to GL2OK for the number field K equals Q adjoined root -2. This is actually pretty easy to see. We'll discuss this later. It's also well known that GL2F3 is a solvable group. Hence, if rho bar E3 is irreducible, the Langlin's tunnel theorem immediately gives the result. So we'll be discussing Langlin's tunnel in chapters 6 and 7, but Langlin's tunnel is a very, very hard theorem. It's one of the hardest theorems that's invoked in the proof of semi-stable modularity. So we'll dedicate quite a lot of time to it, although not nearly as much time as we could and should probably. So that's sub-theorem 2. At the prime 3, mod P irreducibility is the same as mod P modularity, which is very, very interesting. Sub-theorem 2, this is usually called the 3-5 switch. Here's what it says. It says if E over Q is a semi-stable elliptic curve such that rho bar E5 is irreducible, then there's another semi-stable elliptic curve E prime over Q such that both of the following are true. Rho bar E prime 3 is irreducible, and rho bar E prime 5 is isomorphic to rho bar E5. We will show this in chapter 16 as part of a bigger theorem. You can also see the Diamond-Darman-Taylor notes, page 103. Sub-theorem 3, one prime or the other. Here's what sub-theorem 3 says. Let E over Q be a semi-stable elliptic curve. Then either rho bar E3 or rho bar E5 is irreducible, period. We will prove this in chapter 7. Okay? And so now we can finish the proof of everything. I can prove the 3-5 theorem, which as we've already discussed, proves semi-stable modularity, which as we've already discussed, proves Fermat's last theorem. So let's do this. So again, I want to show the 3-5 theorem. Let's just go back and remind ourselves what it says. It says let E over Q be a semi-stable elliptic curve. Then the conditions of the MIM lemma are satisfied by either P equals 3 or P equals 5. What conditions are those? Modular and irreducible. Okay, so let's go down to the proof. So let's let E over Q be a semi-stable elliptic curve. Let's suppose rho bar E3 first is irreducible. By sub-theorem 1, rho bar E3 is also modular. So E satisfies the conditions of the MIM lemma for P equals 3, and I'm done. Well, what if rho bar E3 is reducible? By sub-theorem 3, rho bar E5 must be irreducible because one or the other has to be. By sub-theorem 2, I can find another semi-stable elliptic curve E prime over Q such that rho bar E prime 3 is irreducible, hence modular by sub-theorem 1. Well, that makes E prime modular by the MIM lemma. By the fivefold theorem, rho bar E prime 5 must be modular since E prime is. But since rho bar E5 is isomorphic to rho bar E prime 5 by sub-theorem 2, the same must be true for rho bar E5. It must be modular as well. Okay, well then rho bar E5 is irreducible and modular. And so E satisfies the conditions of the MIM lemma for the prime P equals 5. And so I'm done. Okay. And so again, just to wrap everything up, the proof of the modularity theorem now goes like this in the semi-stable case. Let E over Q be a semi-stable elliptic curve. By the 3-5 theorem, the conditions of the MIM lemma are satisfied by E at either the prime 3 or 5. And so by the MIM lemma, E must be modular. Okay, so starting next video, we'll go into chapter 3 of my notes. We're going to basically, for the rest of this very long series of talks, be filling in a lot of details that we didn't flesh out in the proof of Fermat's last theorem and in the proof of semi-stable modularity. Thanks for watching, and I'll see you then.